Unfortunately, our camera has given up on us today, so we're going to do a sound recording only. And we can broadcast the slides on Zoom and on YouTube, so this will hopefully work. It is my great pleasure today to have a dual talk by two very different people from different disciplines. And Mark Williams, thankfully, has agreed to give a talk on the biosphere in the Anthropocene. Mark is a colleague of mine in the School of Geography, Geology and Environment. And we have Rebecca Chesney here today, who is an artist, and they're both going to give us their take on the Anthropocene. Over to you.
Okay. Thank you very much, Heiko. So the biosphere and the Anthropocene by geological definition would be about the past 70 years, and two of us in this room, myself and Jens, are actually involved in trying to make that geological definition at present. So I started this talk by pinching one of Rebecca's wonderful images, because when I went to Rebecca's website, this is the landing page, and it just grabbed me straight away as a really good metaphor for what you and I are doing to the rest of the biosphere around us. Sorry to say, but that very much is the case. Because we know, various estimates, that many species are already at risk of extinction. Very difficult to quantify this, of course, because we don't actually know how many species are on this planet, but perhaps 1 million or more species at risk of extinction. Did we actually notice this? We certainly noticed the big things that vanish from the landscape. The dodo is the classic example. And others, like the Caribbean monk seal that's not been seen since 1952. Or the wonderful Yangtze dolphin that's not been seen since 2007. Yes, we all know about these because they all make media coverage. How many people in the room or online know about George the Hawaiian tree snail? Because George the Hawaiian tree snail and his species went extinct on the 1st of January 2019. And it's part of a much bigger process of human interaction with the biosphere, which is causing these extinctions and major reconfigurations of the biosphere more generally. And I'm going to come back to George the snail a little bit later to show you how humans are implicated in the extinction of this species. Well, we are already in a large extinction event, and we may be heading for mass extinction. And here I'm just taking a very recent, very good paper published just a year ago, trying to quantify the loss of mollusk biodiversity on planet Earth. And you can see that those places that we normally go to, like the red list, are not really capturing all of the biodiversity loss. And if we've lost something of the order of 13% of mollusk biodiversity in the last 500 years, we're already in a very significant extinction event. Now, for me as a geologist and for others in this room, if you're going to understand present changes to the Earth system as a result of human interactions, then we do need to think about the past also and see what's happened in the deep past to the biosphere. I brought a fragment of the past biosphere with me if anybody wants to hold a fossil. It's a 2 million-year-old snail, so very happy for that to be passed around so you have a connection with what's gone before. And this is really a question about how many things have ever lived on this planet, relative to how many live today. This is the beautiful Chuandionella that we were lucky enough to describe a few years ago. It's a 500 million-year-old fossil, preserved with all of its soft anatomy. It's one tiny fragment of the past biosphere on this planet, because, of course, most of what ever lived on this planet has already gone extinct. The species living today are, again, only a tiny representation of what the past biodiversity of this biosphere has been. It's even a question about what preserves in the fossil record, because if you ask one paleontologist, if you ask Jens, he'd tell you one thing, and if you ask me, I'd tell you something completely different, because it depends on what fossil group you actually work on. So if you work on this group, the trilobites, which are wonderful fossils, there's about 20,000 of them in the fossil record. But if you work on soft-bodied worms, look if you can find half a dozen of them. And that shows you just how fragmentary our record is, that it's selectively preserving some things. Well, that makes it difficult for us to compare the past to the present. But despite the fragmentary nature of the fossil record, it does show us that there have been periodic major extinction events on this planet, certainly 5 of them over the past 500 million years. And we may be heading towards one of these mass extinction level events in the very, very near future if we continue with our present trajectory. Well, we should ask the question, what actually causes extinctions if we're going to think about our interaction with the Earth system? So we know that bolide strikes, for example, big asteroids hitting the planet, one hit the planet 66 million years ago, can cause a mass extinction event. But there are bolides hitting this planet every single kind of week, perhaps every single day. I think my image, there we go, my NASA image is there, showing you the number of asteroid strikes, over the recent period. These little strikes don't cause a mass extinction, of course. It's the really big ones that cause a mass extinction. But I want you and I to think of ourselves as a mass extinction causing mechanism now, as the big asteroid strike. So 4,000 or 5,000 years ago, we were like all of those little asteroids striking the surface of the planet. We were having an impact, but only locally, not really having a fundamental perturbation of the system. But now, in the 20th century, we are the asteroid strike, and we are causing a major change to the biosphere. And the other question we could ask, because it's one of perspective that we should also think about, is extinction a good or a bad thing? We live on a very biodiverse planet, and I've told you that there have been 5 major extinctions in the past 500 million years, and perhaps another 20 extinctions that have also been of major magnitude. We should think what happens after an extinction event, because this will give us some context for where we sit in the role of the biosphere on this planet. What happens after a major extinction event is that some organisms, of course, survive. The generalist species typically survive. So you might expect a world of rats and rabbits and cockroaches after the mass extinction that we cause. I hope we don't cause one. What would happen? Some of you might have read Dougal Dixon's wonderful book, After Man, should be after humans, of course, but this was written several decades ago. And in that book, he explored what might happen to rabbits. Thousands of years, hundreds of thousands of years in the future. You can see here things like the common rabbit and the mountain rabbit. This is what rabbits evolve into as we go forward in time. So the biosphere repairs itself, and it repairs its biodiversity, as we can see in deep time. So this is really, from our perspective, and from the perspective of the biosphere, a problem of time. If we precipitate a mass extinction, it will be a disaster for everything living on this planet at present, or most things living on this planet, a disaster for us. But long term, the biosphere will repair itself. And sorry, I love this image, fantastic website, I think, comparing a pre and post extinction event. Now, extinction is a big part of what we're doing at present, and it's a major part, and it's leaving a clear physical record. But unfortunately, our impact on the planet is much greater than that. And this is where we can measure this by looking at the deep time extinction events. We can see that it's entirely different in its structure from those past events. How so? So over the past 10,000 years, you and I have reduced the mass of the biosphere by 50%, which is a staggering figure, but is now quite well quantified. That's a staggering figure. 50% of the mass of life has been reduced by humanity. And we've tended to concentrate mass in those things that we like to consume. So cows and other animals, which are now something of the order, together with us, of 96% of the terrestrial mammal biomass. Staggering figure, again, to think about. And that's had a profound impact on the landscape. And the figures are really profound, yes. Half of the habitable land is used for farming. 3/4 of that is for animals and dairy. And another third of the land under crops is used to feed our farm animals. No wonder that we are reducing the space available for biodiversity on this planet. And of course, we've also profoundly changed the organisms in those ecosystems. This is what you and I have done to chickens over the past 7 decades, because we like eating them. We eat 63 billion of them every year, 21 billion of them alive on this planet at any moment. And we've increased their individual biomass 4-fold in 7 decades. And we've reduced their lifespan to about 6 or 7 weeks. In the wild, they live somewhere between 8 and 14 years. It's left a fossil record too. We've smeared biogeographical boundaries. We've all read about how Alfred Wallace recognized this major biogeographical boundary in Southeast Asia. One PhD student working in the group that are well represented here today is showing how this is being homogenized by human activity. Golden apple snails, for example, come from South America and have now dispersed across Southeast Asia. They couldn't care less about the Wallace line. They're quite happy living in rice paddy fields across Southeast Asia. And for me, this is the kind of organism that will leave a clear fossil record. Snails are really good at leaving fossil records, as I hope the snail that's finding its way around the table is proving to you. These patterns are a wholesale change to the biosphere. That change is unique. There is nothing like it in the geological record. The extinction event, yes, has precedence, but the other components are completely unique. Can't find anything like this. Let me show you a place where we can measure this. But there are several people in the room who are actually measuring this in the local landscape as well. But I want to show you San Francisco Bay because it's a classic illustration of how we have reconfigured ecosystems and life on this planet. And this is very much the work of a previous PhD student, Stephen Himpson, who just got his PhD in December. San Francisco Bay is a hub port in the Pacific. So it's a place where there's lots of shipping, transporting materials across the Pacific, and of course many organisms stow away on these human means of transportation. This is a very important study that was done a couple of decades ago, which Stephen has now embellished very considerably. I mean, it's just showing you the number of species that have arrived in San Francisco Bay in the aquatic realm over the past 150 years or so. And also notice that half of the introductions of species are in the last 50 years or so. So it's part of an accelerating process that we see globally as well. And the figure here that I think is really staggering is that in some parts of San Francisco Bay, 97% of the organisms and 99% of the biomass is introduced species. There is almost nothing left of the original ecosystem. It has been obliterated. And in many cases, those species are invasive in the sense that they actually do cause real ecological damage to the ecologies around them. So the manila clam, what on earth is that doing in San Francisco Bay? You know, it arrives in the middle of the 20th century, and you can see what it does. It proliferates. 2,000 individuals per square metre, obliterates space for other organisms. So some of these species, when they're translocated from their home ecology to new ecology, take on a completely different ecological role. They go from being Dr. Jekyll into being Mr. Hyde. This is another one. This is one that Stephen documented in a lot of detail, and you can recognize it in the sedimentary cores in San Francisco Bay. This is the Amur River clam. What on earth is the Amur River clam doing in San Francisco Bay? Because it comes from East Asia. You can see the figures here. It arrives in 1986. After a couple of years, 2,000 individuals per square metre. After a few more years, nearly 20,000 individuals per square metre in some places. It obliterates the local ecology. It's an invasive species in the classical sense of that usage, ecological usage. It's not the only one. On the right-hand side there, you've got a foraminifera. This is a tiny unicellular organism that makes a skeleton. And they're global in their distribution in the oceans. This one, Trocomina haydai, comes from Japan. It's been living in the seas around Japan for probably a couple of million years. And then it turns up in San Francisco Bay in 1983. Another uninvited guest. And it basically outcompetes the local organisms there. It's now become the dominant foraminifera living on the seabed in San Francisco Bay. So another example of ecological displacement. Now, in many places, these changes are irreversible, and not just in San Francisco Bay. We could go and look at the Leicestershire landscape. Amy could tell you about what's happening with introduced species in the Leicestershire landscape, but I just want to use another kind of high-profile example for you, because I talked about George, the Hawaiian tree snail, right at the very start of this, and the demise of those tree snails is very much linked to human activities and human translocation of species, human translocation of other species. Why on earth did we translocate the giant African snail into the Hawaiian Islands? It has no purpose being there whatsoever. We did that in the middle part of the 20th century. And then for good measure, we transferred the cannibal snail because we thought the cannibal snail might actually control the giant African snails. Cannibal snails eat other snails. And so they ate their way through the indigenous snails also. And George, the Hawaiian tree snail, and many other snails are probably owe some of their demise to these snails. So that resulted in the extirpation of many indigenous snails. And that has left a clear physical record. So wherever we look on this planet, Jens and I and others have been looking, and Amy and Anna and Molly and others in this room, you can see a clear fossil signal of this. So here, this is a study from 2 decades ago, before we were really talking about the Anthropocene. In the bottom of this sedimentary succession, in this sinkhole, you see fossil snails that are indigenous. And then at the top, they've all gone. And what you see is the giant African snail and the cannibal snail, leaving a fossil record. A clear geological signature of a changed ecology. And that signal we can pick up wherever we look on this planet. So as a geologist, I would say to you that there are 2 likely outcomes to the near future, and I think you probably all know this already. The human changes to the Earth system become short-lived and unsustainable, and they're marked with an Anthropocene mass extinction. We're not quite there yet, but we're not far off. Very good marker for me, brilliant for me as a paleontologist. I can definitely recognise that anywhere I look. Really disastrous for the rest of the Earth system. What we need to evolve, of course, and what many people in this room are working towards, and why the Institute for Environmental Futures has one of its mainstays, I think, is to work towards a situation where we develop much more mutually beneficial relationships between the Earth system and its human component. And we have to do that quite rapidly. Even then, though, I have to say to you that even if we achieve that, we will have completely reconfigured the biosphere on this planet. And either way, mass extinction or not, this will leave a very distinctive fossil signal of our impact on the planet, which will be long-lived into the future. Where we go next is very much in our hands. And this is the other big contrast, I think, between the deep time extinctions and this one. The deep time extinctions were not purposeful. We are purposefully causing this mass extinction. That's a terrible moral dilemma for us, I think. And at that point, over to Rebecca.
If you don't know my work, which a lot of you won't do, but I know some of you have seen me talk before, so I'm sorry if I'm about to repeat myself. So I've been making artwork for over 20 years, looking at nature and our relationship to the landscape. I've made work about bees, weeds, weather and extreme weather, water quality, air pollution, rising sea level, declining species, invasive species, and habitat loss. And I know that sounds like an awful lot of subjects, but as you all know, they're pretty much all connected. I use lots of different media, video and sound, drawing, printmaking, embroidery, installation, things like that. I've picked out a few projects to talk about today. Ones that I think give you a broad overview of my practice, but that are also connected to the patterns of change. And one thing I want to mention is most of my projects are really big, and they develop over time, and pretty much one is connected to the next one. So sometimes they're almost not separated, or they overlap each other. And they generally involve lots of different people giving me lots of information, or I'm working with lots of different people. And of course, they're best experienced in person. But I've tried to condense some of the projects so that I can present them in a kind of a best way for you to see them. And I've included some smaller works as well, sort of works on paper, to give you an overview of what I do. So this first slide, I was invited in 2016 to attend a residency at Montalvo in California, so just south of San Francisco. And at the time, in 2016, California was experiencing one of the most severe droughts on record, having just finished a winter. So when I was invited, it was like, so I'm from Lancashire, if you've not picked that up. And it's like, what is my experience of my landscape? What's that got to do with California? But at home, Lancashire and Cumbria had just gone through the devastation of storms Desmond, Eva and Frank. And so I was interested more in looking at extreme weather episodes and sort of learning more about sort of where I am, but also California in the drought, and how climate change was affecting both places as a general sort of starting point for what I was looking at. So split into 2 trips. My first visit in 2016 was 5 years into the drought. So dry riverbeds, reservoirs at historically low levels, and the outbreak of wildfires nearby all revealed the extent of the drought to me. It was just really obvious, like we could see the wildfires on the horizon. But what made the biggest impact on me was the sheer number of dead trees on the hillsides in Yosemite National Park. And as so it was September, and I was doing the British sort of thing of going and being in the landscape, and beautiful, absolutely vast landscapes of ranging hills. And it's like, oh, look at the lovely autumn colours. And then actually you sort of focused in more, and it's like, actually, these are swathes of dead trees. These are not autumn colours, these are dead colours. And that had a big effect on me. And there was thousands and thousands of dead trees. So because of the drought, the trees are susceptible to bark beetle attack. And that's what is really sweeping through a lot of the forests, along with, of course, a rise in wildfires. And the US Forest Service estimated a loss of 66 million trees in the Sierra Nevada in 2016. Anyway, during my travels, I started to make drawings in my sketchbook of the exit holes of bark beetles found on dead branches and tree trunks. And that's what this image is. It's through my sketchbook. I was drawn to the random patterns made of tiny holes, singularly meaningless, but collectively devastating. So these tiny sketches actually holding all that information about the loss of trees. How do you reckon you go forward, Sam? Yeah, I've done the arrow down. Here we go. Sorry. So during my second trip, I was invited to meet Ramakrishna Namani, a senior earth scientist at the NASA Ames Research Centre, which there's a picture there on the left-hand side, and also Professor Eric Lamin at Stanford University. Namani's research uses satellite and climate data to produce ecological nowcasts and forecasts, while Lamin's research is looking at land use change using GIS, remote sensing and socio-economic data. I also attended a sudden oak death citizen science BioBlitz research project at UC Berkeley, and that's with that's the 2 right-hand images, and sort of meeting these people and talking to them and hearing their research, but also doing sort of a little bit of field research, I suppose, well, helping with somebody else's research, all inputs into what I'm thinking in the work that then I'll make. Okay. So continuing on from my work about tree loss and the tiny little patterns, I used data supplied by NASA to produce a series of prints. And they're showing tree loss caused by the drought and bark beetle attack in a 4-year period, 2013 to 16. Well, I've taken out all reference of scale, but they are of the Sierra Nevada. The resulting images, see, I'm going to have to do that every time, I'm sorry about that. The resulting images look like, I mean, they're quite, at first glance, quite pleasing, I think, in a sort of a random way, but very swarm-like, very intense in some places, oh, it's doing it now. And sort of sparse in others, and they're quite big. And of course, you don't know what they are. I've taken out all reference of scale. It's only when you read the description that then, you know, you're drawn to them, but then maybe repelled by them at the same time. So that shows you, so of course that project took quite a while, and I made other works during that time, looking at land use and water resources, and I'm still using some of the things that I gathered in America and still making work now. But on to this next project. So the Newlyn Tidal Observatory, so the picture on the left of the lighthouse, the tiny little shed with a red stripe across it, that's the Newlyn Tidal Observatory. And it was established to determine mean sea level as a starting point for measuring height and levelling throughout the UK, and provides the longest sea level records ever kept. And I was invited to do a project down at Newlyn Art Gallery, and sort of hearing this piece of information, I was like, oh, that sounds interesting. I wonder if I could do something with that. So I got permission to access the observatory in 2019. So the button on the right-hand side, that little brass button, is all heights in the UK are measured from that point, which I think is quite interesting. These are the records, because they started gathering records from 1916. And my records went up to 2017, and then I made the drawing in 2019. So with this data, like, what do you do with that? It's like, this is a massive thing. I produced a 8 3/4 metre long drawing showing over 100 years of mean sea level data recorded at Newlyn. So this is 10 years, this is 1981 to 1990, I think. So each card has got then the sea level on. And that on the left-hand side of the gallery shot is the drawing all in one go. So that's all 102 record cards, I think. But of course, as you walk along it, it sort of undulates, but then towards the end of the drawing, you can see that it rises. That's this. So a curator called Ellen Mills wrote about this work, and her words can capture it very well, better than me. So the piece is called With Far Heard Whisper O'er the Sea. And she's put, with far heard whisper o'er the sea, a line from Samuel Taylor Coleridge's The Rime of the Ancient Mariner, written in 1797. The drawing is beautifully effective with the simplest of lines, depicting an overwhelming truth. The piece comprises 102 record cards, each card being a year and a single pencil line drawn across it, representing the sea level height for that year. Both a border or limit and a way forward, the line is a useful tool for an artist and the very essence of mark making. Here it might also be interpreted as a horizon. Chesney's piece is one long line made up of several short lines, combining to make one gently undulating but ultimately rising contour. So with just paper and pencil, again, it's one of those works on paper where you're sort of drawn to it, not sure what it is until you understand what it is, if you see what I mean. And then, of course, those lines hold 102 years of data and the issue of rising sea levels. So continuing on, sort of looking at water themes, I've spent quite a lot of lockdown embroidering new imagined future water lines on old maps. I had more time in the lockdowns, so I could spend a lot of time embroidering. So this is one of London. I did also ones of North Wales and the Liverpool coast. There's Bristol Channel, I've done Venice, New York. And So that's it close up. It's double-sided as well, so hence it sort of being on a plinth in the middle of the space. So I've deliberately used maps from the past, but they're embroidered in the present, imagining the future. I mean, obviously coastal spaces are dynamic anyway and change, I would suspect, like twice a day. But of course, things are changing more rapidly. When I make these maps, I do use freely available open source flood data. But I also combine it with doing whatever I feel. One of the best bits about being an artist is you can do what you like and ignore the data in one way. But of course, I want it to be believable at the same time. So in this instance, I've used the data to understand the lay of the land and what is predicted to be flooded. But at the same time, I've saved certain areas that I don't think deserve to be flooded, and maybe we should do more to save them. But also then I have deliberately flooded, for example, here, Buckingham Palace, flooded Buckingham Palace, but saved the gardens. You just that little wee peep there. The flood raged through. And this is the Great Orme's Head to Liverpool map. And of course, I'm creating new island systems, I suppose. Yeah. It's interesting when I show these maps, because if somebody, especially the London map that was shown in London, people do then look up where do they live now or where did they used to live and will it be flooded? And it's like, it's an embroidered map, but you know, they're actually like, oh, I'll be saved. So I think it's quite interesting. So here's some of I've created Great Orme's Head Island, I suppose. And then on to my last section of work, I suppose. So I've got a 1950s copy of the popular Handbook of British Birds by P.A.D. Holland. I don't know about you, but I've got like masses of bird books. If I just see a bird book, it's got nice illustrations in it, then I'll buy it, as like from charity shops. And so with one of these, I decided maybe I should do like with the future maps, maybe I should do a future edition of it. Because it's full of illustrations. So this is my imagining of the feature edition of Popular Handbook of British Birds. And what I've done is I've blanked out all the birds that are currently on the red and amber lists of the UK Birds and Conservation Concern lists. So that's red, amber and green. I know most of you will know, but I'll mention this anyway. The red list is a list of birds in the UK, Channel Islands and the Isle of Man of most urgent need of help. This is plates 1 and 2, and 3 and 4. And the RSPB has written this on their website. The first UK Birds of Conservation Concern report was published in 1996. Roughly every 6 years, experts from different nature and conservation organisations get together to update the report. Each type of bird is assessed and put on the green list, the amber list, or red list, depending on level of concern. Now, the book is quite old, and I mean, there are some really odd additions in the book anyway, so I did sort of blank them out anyway. There was flamingo in it and things like that. But about halfway through the book, so we're now on to 5 and 6, bearing in mind there's over 200 plates. I'm not going to go through all 200. So that we're already on to plate 100. About halfway through doing this, I was beginning to get like really depressed. Like, this is ridiculous. If I put all of red and amber in the book, if I blank them all out, there really isn't a lot left. So again, I started to save some of the species and hoped that in the future we wouldn't let a lot of the species that were looking like they're going in the wrong direction in my imagined new book we have saved some of the species. And this is 93 and 94. I mean, there was whole pages where there was potentially only one bird left. I've not had a chance to show this all in one place, but this is a handful of the 200 plates on my workbench. So you sort of get to see them all together. And of course, en masse, that's when the message comes home, I think. And that's the end. There's another quite depressing talk. I have to say, I do make lots of other work, and some of it is about the beauty of nature. And I do also make work about trying to create new habitat. So in appropriate areas, usually in a park, or sort of civic areas, I will develop the area to plant wildflowers and trees. So I think maybe we should end on that. Okay, thank you.
Thank you, Rebecca. Thank you, Mark. Would you two like to come to the front, and we put the microphone on the table so you can answer questions?
Yes. Yeah.
I think there is no nice way of talking about species extinction generally. No. Although there are some positive developments like rewilding initiatives and initiatives like the COP15, where there's clearly a will to do something about it, but are we doing enough worldwide? Probably not at this stage. So, food for thought. I'm opening up for questions and answers. Yes.
Thank you very much, both of you, for really interesting talk. I mean, I guess virtually everyone around here is involved in producing work about this subject that's going to go out into the world and hopefully enact some kind of change eventually in human behaviour. That's the, you know, however small, that's the ultimate aspiration. But I wonder, it's a question for both of you really, in those terms, what do you think art can do that scientists can't?
Okay, I'll try to repeat the question briefly for the online audience, if I may. So the question was what art can communicate that science can't, more or less. A question to both presenters.
I would say the impact of art is visual often. Like I work in visual art, so of course, obviously it can be literature and dance and theatre and music, but my expertise is visual, and of course a visual image can say a lot. And I think we have to try lots of different ways to sort of talk about it. I mean, when I've said that I can ignore the data, I don't know how scientists would, you know, how they would do that to get there. Maybe you have a path, but my path might be slightly, you know, I can know what I know and I can try and get it across, but then I can bend it slightly to just kind of make it maybe a little bit more impactful, if you see what I mean. And also as an artist, I can pretty much do what I like, you know, we're talking within reason, but so I can make up things. It can be imaginary. It can be imaginary in a positive way. Let's look at the future in a positive way, but let's also see it at its absolute worst. So maybe as an individual, maybe my range might be a bigger scope. I don't know, because yeah, I mean, I do a lot of my work and I make connections to scientists. I like to know what I'm making work about, if you know what I mean, and talk to people. I get invited to meet with people and chat, and a lot of these discussions are like really, really make a massive difference. I can't do it without that. So maybe that is a great combination, if you see what I mean. So everything that I've chatted about, I mean, we chatted a lot over lunch, and it'll definitely go into what I'm thinking now, but things that I'm thinking into the future, because I want my work also to be believable at the same time, even if it is imaginary. Do you sort of see what I mean? So maybe that's one thing that art can do. I think the combination of arts and sciences, and we talked about this, is getting more and more regular that arts and sciences are getting together. I would say it wasn't, so because I've been doing this for quite a long time, I'd say at the beginning it wasn't, or I was just not persistent enough to get in to know people, if you see what I mean. And I found that some, like a lot of scientists, individuals, not all of them, not really sure what art could do for them. What's the point of art? It's it's not even in our thing, And actually, those barriers are being broken down, and because we've always, we've been told science is good for us, so we've always embraced it, but it's never been that mutual thing. But it is more now. So then, and I think we're even down the path of, because I think at first a lot of scientists thought that art could be useful to them to get their ideas across, which of course it can be, and to illustrate their work, but they didn't understand there was that conversation that you could have. You could both come to it as equals and actually question each other and answer things together. But that is happening more, I would say.
That's the great answer. I can't really add anything except the one thing I think is, if there's a strapline from today that we'll all remember, it's your images of the birds in silhouette. That's embedded in my soul. I don't know about everybody else. And I think if you wanted a better illustration of how art can convey the problems around us and the solutions, I guess, too, then I think that was brilliant illustration of it. Thank you.
Oh, well, I mean, it was a depressing project, about halfway through. I'd run out of grey for a start off. I had to remix it. You want to know how tricky that is with grey. Yeah.
Thank you. We have another question here.
Yeah, so sort of following on from that, you've mentioned a few times about how, as a subject, it can be quite depressing and make people feel uncomfortable. Do you think that sometimes gets in the way of people engaging with the research and the art around this subject?
Yeah, I can have a go at that. Yeah, I mean, I absolutely agree with that, Ed. So for many years, and I'm sure many of us have had this experience, that we're asked to give talks, and we go out and we talk about the state of the Earth system, or we talk about the state of the biosphere, or I used to work for the British Antarctic Survey, so I used to talk about the state of the Antarctic ice sheet. And you can see that people are really confounded by it, because I guess we feel, what can we actually do about it? So I think that's changed very dramatically over the past few years, and I think the Institute for Environmental Futures is a classic example of that. Is that we're now thinking in a much more multidisciplinary sense of how we can actually find really good solutions to this. So we've done a lot of the doom-mongery, and I'm sorry for doing more doom-mongery today, but it was kind of the remit of what we were going to talk about.
Yeah, we did. Yeah, I wouldn't normally put quite so many depressing projects together. But I think I would say, so I've been making work about this a long time, but of course it's morphed. Like at the very beginning of making work, the sort of phrase climate change wasn't even in. I mean, it will have existed, but not in general conversations, if you know what I mean. So I would say I was making work about our impact on nature and landscape, sort of politics of landscape, management of landscape, the British landscape. And of course, all these things sort of overlayer each other, I think what's interesting is, of course, all of us are becoming more aware of, the climate crisis is now crisis. I did a project a few years ago on air pollution, and so it was only like 2015 that I started. It was right at the very beginning of you'd be able to get portable digital monitors, just right at the beginning of that. And I linked in with the University of Central Lancashire, and they sort of helped me with monitors. And I was looking in Preston, and I linked in with lots of different people, like pollution scientists in Southampton and places like that. And I wanted to look at it in an environmental way, but a couple of the scientists did mention that it was the way it was phrased seemed to get the general public to then be more engaged with it. And they shifted it from being an environmental issue to being a health issue. And so when it became more about self, as usual, it became, it was more regularly talked about. And they said that they found that more people were then engaged. And of course, that's one of the big problems, isn't it? We think about ourselves, but maybe not as a whole thing, not the whole environment of us being all connected, if you see what I mean. We see ourselves almost as quite separate from it. Yeah, but maybe we are changing a bit more.
And I was wondering, is there a message or a feeling that you want the audience to have when they experience, I guess, that portion?
So let me just repeat the question briefly. The question is there a sort of message or a feeling that Rebecca is asking, is expecting the audience to have when looking at the art installations?
Yeah, it's a good question that. You can't really ever predict you can think about what you want people to think about a piece of work, but there'll always be extra views on top of that. So you can't always predict what they're going to feel when they see it. I think with some of my work, and almost particularly from lockdown onwards, so 2020, so it's only the last couple of years, I think my work has become more sort of not as subtle, maybe. You don't have to dig too deep to understand what I'm on about, if you see what I mean. So I am being a bit more blatant, I think, it's like, look, half of London might go. It's like, you can't really get more, that's not subtle. I think it was interesting seeing people looking at the flood maps of London and checking out where they lived. Again, the self thing, will I be all right? Oh, I used to have a flat there, that'll be flooded. But now I've moved to a nicer area. It's usually about that, isn't it? Yeah.
Can I ask a question? Is it as a follow-up to that? So you're talking about the individual and how people, once they individualize it, can think, oh, that's a threat to me. Yeah. But do you get a sense that people are actually thinking about how they might modify and change their behaviours so that we don't go to these bad places? I mean, do you get a sense of that?
So when I'd say no, really. It starts conversations and people are always telling me things about their experiences. So yes, it starts conversations, I would say. I'm not sure if I could absolutely say that people are going to change, the work is going to change what they're going to do. When I said about that last project that's not any visuals, so I was given the permission to take over a tiny little derelict plot of land. It was like owned by the council, little parkland on the canal, and I was commissioned by an organisation called Super Slowway to then develop the park. So it's a park, and I then spent all of last summer developing it by stripping off what was there. It was like really overgrown and pretty nasty, like loads of people were dumping on it. So cleared out all the turf, because it was like really high, and I replanted it with sort of native wildflowers and a few like cherry trees and rowan, things like that. But because being connected to the site all the time, then locals would walk their dogs through it and come through all the time. We got to meet people regularly, and the businesses. It's on like this little industrial estate. It's not pretty at all where it was, but we then made this really nice little place with park benches for everybody to use. And what was kind of nice about that was the comments about how it made people feel, how things like this and groups together. So the locals actually set up, they do the litter picking on it. And that's been set up by them. And so I think sometimes things are too overwhelming to do it on your own. So everybody knew that park, knew it being neglected for a long time, but how do you do that as an individual? But it didn't take actually a very big lot of time and effort, but it just needed that little bit more. And that's then that brought everybody together. So I think that there is the possibility for that with lots of different projects, not just my planting things, but But when people can see there's a solution maybe, or possibilities of solutions, I think that, I know we've said how negative it was today, but there are solutions and there are things and there are people doing lots. And I think that the more that happens, then you do feel like, yeah, we're actually doing it collectively. And I got that from that plot of land, is that everybody kind of, you know, the local high school got involved in scrubbing the pavements and doing the benches. And do you see what I mean? So it's like, actually, these people were already there and all thinking about the park. It just needed that one little nudge to get it going. And of course, you can do that in any walk of life, surely.
Thank you. We have used up our time more or less. So thank you very much, both of you, for your presentations and for the discussion. I think for me, the core positive message in both your talks really was about the fact that it is our choice which future we end up in. And so I think both in the artist's representation of what's happening, I think it's important to bring that home to people, what is happening. But also there is a possibility, it doesn't have to end up this way. And the same for Mark's talk on the science of species extinction. How many species will be lost from the planet and how we change the planet ultimately is down to how we behave as humanity. So thank you both of you, and thank you for the audience and also for the online audience for attending and watching today. And if for people in the room, if you want to stay for a cup of coffee, then please do. Thank you very much.